This video we are going to talk about gamma distribution. Gamma distribution is a generalization of exponential distribution. It can be considered as a continuous waiting time distribution and in a sense a continuous analog of negative binomial distribution. So we start with the definition first. What is the gamma distribution? The probability density function. Those things we start first. Okay. So gamma distribution first is the definition. A continuous random variable x is said to follow a gamma distribution with the parameter lambda positive and alpha is positive if it is probability density function is PDF is given by f of x equal to lambda time exponential of minus lambda x times lambda x power alpha minus 1 divided by gamma of alpha. Here x is always positive, non-negative, not positive, 0 otherwise. This is the so it is the gamma. Some people they call us it's a general gamma distribution also. This is the my PDF. Okay, this is my PDF. This is the probability density function of gamma distribution. Here you look why it's a generalization of gamma distribution is if I choose alpha equal to 1, so this guys become the exponential distribution. That is why it is a generalized distribution. So you know what is the property of this is the Euler gamma function. The definition everything we already posted in our in this video channel, in this YouTube channel. I will give in the description. Okay, the link of the gamma. What is the gamma function? Okay. Some people instead of lambda they choose to say 1 over beta. That way also they will provide. That is lambda equal to 1 over beta. Some books or some people they will provide such a way that also the gamma distribution. First step, whenever lambda equal to 1, okay, this is the gamma distribution. Suppose I choose lambda equal to 1, then my probability density function f of x become exponential of minus x times x power alpha minus 1 divided by gamma of alpha. Whenever x is greater than or equal to 0, 0 otherwise. This is known as the standard gamma distribution. this type of probability density function we define mean that is lambda equal to 1 we I choose mean we call this is standard gamma distribution. Okay. Next, I want to say what is the mean and variance. What is the mean? First step, I want to find what is the mean of the gamma distribution. The mean is always denoted by Greek letter mu is alpha over lambda. The variance is always denoted by Greek letter sigma square. Sigma means square root of variance is our standard deviation. Sigma means standard deviation. Sigma square means variance. Variance equal to alpha divided by lambda square. This is the mean and variance of gamma distribution. Next, we are going to solve few problems. Daily consumption of bread in a hostel in excess of 2000 loaves follows a gamma distribution. Approximately with the parameter lambda equal to 1 over 1000, alpha value is 3. The hostel has a daily stock of 2500 loaves of bread. Then what is the probability that the stock will be inadequate on a day? Okay. Now I want to write what are they given first. First, what is our random variable? Let's say x is a random variable. It follows the gamma distribution and it denotes the quantity of bread consumed daily. Let x denote the quantity of bread consumption daily. So it doesn't, the x follows the gamma distribution? No, because they clearly mention in excess of 2000 bread loaves only. Okay. So then I will say that now I define the new random variable, that is y, that is x minus 2000. This is a random variable. This follows gamma distribution. Y follow gamma distribution. This is the they given. Okay. Next, what are the parameters they given? Lambda equal to 1 over 1000 or 0.001. We can take, and alpha value is 3. Then what is the probability density function? That is formula. We write it as probability density function. F of y equal to lambda times exponential of minus lambda y times lambda y whole power alpha minus 1 divided by gamma of alpha. Here y is greater than or equal to 0 otherwise. This is our first thing, correct? So they are asking that what is the probability of x greater than 2500. So that meaning is probability of y greater than 500. This way we convert. Then this is after that very simple only. Simply integration only. 500 to infinite f of y times dy. So only the, if you are integrated, you will get it, the value is suppose f of y is 1 over 1000, and so here we can write this alpha value, we know that is alpha value is lambda value is 1 over 1000, alpha value is 3. So we will get it as 1 over 2000 because gamma of 3 is 2 factorial. That's why it's 2000 will come times x integral over 500 to infinite exponential of minus y over 1000 times y over 1000 the whole square times dy. This way only the I write it. Now my aim is I want to integrate, correct? So please carefully integrate. You take it as t equal to 1 over 1000. This implies my times y dt equal to dy divided by 1000. So whenever t is going to 500, my y is going to 500, my t is going to 1 by 2. So that is the idea. So y is going to 500, this implies t is going to 1 by 2. Simply apply this value, you will get the answer. Then y tends to infinite, t also going to infinite. So then next step is, so dy, so 1 over 2, we get 1 over 2 integral over 1 by 2 to infinite exponential of minus t times t square dt. You apply the integration by parts twice, you will get the answer is, so you apply the integration by parts formula. Here some few steps will be there to integration, apply integration by parts formula. You will get the final answer is, you will get it as minus 1 by 2 exponential of minus t times t square plus 2t, so minus, okay, 2t plus 2. Apply 0 to infinite. This is the value. So whenever you apply infinite, you want to use this result. First of all, this both guys going to infinite. Okay. But we know that exponential is going to faster approaching 0 before t square is approaching to the infinite. So otherwise you can apply the L'Hospital rule. You will get the answer is, this is the only dominating guy. So minus 1 over 2. So upper limit you will get the 0. Whenever you get the lower limit, you will get exponential of minus 1 by 2. Sorry, here not 0, 1 by 2. 1 by 2 times 1 by 4 plus 1 plus 2. So your final answer is, if you are evaluating this value, or you use the calculator, much easiest way. I use the calculator value only, 0.9856. This is the probability that, so I will conclude that the probability that the stock will be inadequate adequate on a day is not by 0.9856. This is my probability. Problem. Suppose that the time in hours taken to repair a TV in a random variable having a gamma distribution with parameter lambda equal to 2, alpha equal to 3. Then what is the probability that the next service call will require at least 2 hours to repair a TV? So this is the question they provide. So first they given is this is the follows the gamma distribution. Okay. So I will first write what is my random variable. My random variable I want to write first. Let x denote a random variable. Let x be a random variable. Yeah. Gamma distribution random variable. We write gamma distribution random variable. Okay. Gamma distribution. So random variable follows gamma distribution. We can write that is much better. It's a random variable follows gamma distribution. What is my denote? The x denote they given time taken to repair a TV. This is the time taken to repair a TV. Denote the time taken to repair a TV. So this is, then what is the given? They give the alpha lambda equal to 3 and alpha equal to 2. So what is the probability density function of gamma distribution? That is my formula. This is the given I want to write. I forget to write. This is the given. Please write first given, then only you can easily understand what the problem is asked. Then you write the formula f of x equal to lambda times exponential of minus lambda times x times lambda x power alpha minus 1 divided by gamma of alpha. Whenever x is non-negative, 0 otherwise. This is the first you want to understand. You first write, then you apply the lambda value here. What is the lambda value you apply here means you will get it as 3 times exponential of, sorry, I wrongly written. So lambda equal to 2, alpha equal to 3. I wrongly written. Please correct it. So lambda value is 2, alpha value is 3. Sorry. So lambda equal to 2 times exponential of minus 2 times x, 2 times x power 3 minus 1 is, we write square, divided by gamma of 3 and 0, otherwise x is non-negative, otherwise. So you write it as this one is gamma of 3 is, you will get it as here 2 and 2x square means 4, so it normally cancels, so you will get it as 4 times exponential of minus 2x times x square 0 whenever x is non-negative, otherwise. So we simply, this is 2, this 2 cancel, 2 square is 4, I write it that way. So 4 times exponential of minus 2x times x square. So what is the given? Now what is they ask? So they find the at least 2 hours. So I want to write p of x is less than or equal to at least 2 hours. So waiting hours at least 2 hours. That means so greater than 2. So I want to, this is 2 to infinite f of x dx. This only I want to find. So clearly integral over 2 to infinite 4 times x square exponential of minus 2x dx. If you are integrated, again you have to apply the integration by parts. Twice. You will get the answer is exponential of minus 2x times 2x square plus 2x plus 1. 2 to infinite, you apply the similarly you apply whenever x tends to infinite, this guy is going to 0, this guy is going to infinite, but exponential is fasterly approaches the 0, that is why this first upper limit is going to 0. Otherwise you can use the LHospital rule, minus exponential of minus 4 times 30. So you are applying the calculator, you will get the value approximately 0.2381. This is the probability that the next service call. So I want to write in the conclusion part. It's the conclusion. The probability that next service call will require at least 2 hours to repair a TV is 0.2381. So that means is 23%. I hope you understand what is the gamma distribution, then what is the mean, what is their variance, and how to approach the problems. Suppose you have any doubts, please post in the comment box. If you have any concern on this video also, please post in the comment box. Thank you for watching this video.